Thanks very much for inviting me to speak at this new online conference. I'm very honored. I have two concerns that I want to talk about today, one about testers and the other about test automation. A few years ago, I heard a very compelling keynote at a major software testing conference in the States. It was an interesting story and well presented, but at the end I was left feeling that something was very wrong. The speaker described how they had, quotes, converted half of their testing staff to being automation tool coders, in other words, toolsmiths, and how wonderful this had been. The speaker was full of enthusiasm to finish the job and convert all of the rest of the testers to toolsmiths as well. I did wonder how enthusiastic the other half of testers would be, but what really horrified me was the way that she was selling this idea as the way forward for everyone. My response in a lightning keynote that afternoon was to tell the following story about two people both working at the same company. Leslie has a degree in computer science, started out in a traditional test team, and now works in a multidisciplinary agile team. Les is a person who likes to turn a hand to whatever needs doing and enjoys a technical challenge. Les is very happy to write code and has recently started coding for the test automation tool, making sure that good programming practices are applied to the testware and the test code. Les is very happy as a developer tester, also known as SDET, Software Development Engineer in Testing. Alex came into testing through the business side. Started out being the one user who was always a bit more interested in any new release from IT than the other users. Got drawn into the user acceptance test group and enjoyed testing. Found things that the technical people missed due to having such a valuable business background. With training in testing techniques, Alex has become a really good tester, providing great value to the organization. Alex now saves them hundreds of thousands a year, not just by finding things that the developers missed, but also by advising on new development and testing from a user perspective. Alex never wanted anything to do with code, but just loves testing. Now, what will happen if the CEO of that company was at the conference and hears, all testers should learn to code? Well, Les's job is secure, so she's all right. But what about Alex? I suspect that Alex is already feeling less valued by the organization and is worried about job security, in spite of him having provided a great service for years as an excellent software tester. Well, of course, that was a while ago now. What about now? Well, a few weeks ago, I came across a diagram that really made my blood boil. It popped up on LinkedIn, maybe you've seen it too. It shows an outline of a person in a yoga position with the title 7 Chakras of Tester, with 7 tools distributed over the body. It is so totally wrong. Where the brain should be, there is a tool. Where the backbone should be, there's a tool. Where the heart should be, there's a tool, and so on. The text with the diagram says, if you control these, your life will be invincible, which is utter nonsense for anything, and even more so for the use of tools by testers. As someone once said, a fool with a tool is still a fool. Now, to be fair, perhaps the person who posted that didn't know any better, maybe they're new to testing, and also I think they were probably just reflecting what the current attitude is. But it's the current attitude that I think is wrong and dangerous. Well, this brings me to my second concern about automation and its limitations. What are tools good for, and what can't they do? You might be thinking by now that I'm anti-tool or anti-automation. Absolutely not. If you had read any of the 3 books I have co-authored on test automation, please see Exhibit A, 3 books on test automation, you will know that I've been in favor of using tools in testing for a very long time. Tools and machines in general are really good at doing robotic, repetitive processes. People are not so good at that. They make mistakes, they find it boring, and they're a lot slower than a machine doing that type of task. Automation is most beneficial at the code level, component, API, unit level, whatever you call it, the smallest pieces of code that can sensibly be tested. This is where small tests repeated over and over with every change, with every update, can give you confidence that the main things are still working, and they can flag up a change that has a serious unwanted effect. I don't remember who said this, but it's very true. Test automation is actually change detection, and it's very good at that. But the testing at this level is limited. Actually, all testing is limited. But it's only checking for some things. If there's something that isn't specifically tested for, no matter how catastrophic it is, your tests will happily turn green and give you false confidence. This is even more true at higher levels of testing, since the most thorough testing is usually done at the lowest levels, nearest the code. You might check every code branch in a unit test, but a user acceptance test that includes that module might only exercise 2 of those branches. So automation is useful, but it does miss things. A lot of people are wary of automating at the higher levels. They believe it's difficult to automate at the GUI level, and that these automated tests are fragile and expensive to maintain. Unfortunately, many people do manage to create fragile, expensive to maintain tests at this level, but this is because their automation isn't done well. Good automation at higher levels must have levels of abstraction built in, so that changes to the GUI do not derail the automated tests. Building robust and easy-to-maintain tests isn't difficult to do, but it does require effort, and it should be built in from the beginning. Have a look for abstraction levels in the wiki testautomationpatterns.org, or have I mentioned there are some good automation books out there. So tools aren't perfect, they leave gaps, they take effort, but what's even more important is to realize what tools do not do. A tool does not define what it will be testing. It does not understand why this should be tested. A tool does not decide what's most important to test and what can safely be left out. Tools do not learn from what they've just tested and spontaneously create better tests. Tools do not have aha moments, such as, if this is wrong here, something similar might be wrong somewhere else. No tool will ever challenge an assumption. No tool will have an insight into a user concern or behavior, and no tool will ever think of how things might go wrong. Tools do not think. They have zero intelligence. They just do as they're programmed to do. They are mechanical repeaters of their instructions. They do not instruct themselves, they follow instructions. Well, we're considering automated testing, so what is testing? The essence of testing, I think, is to ask and to challenge. Asking stupid questions is an underrated skill, I believe. Even calling it manual testing doesn't seem quite right to me now, with an implication that, like manual labor, it's less worthy work. Why not call it human testing, or as Julian Harty calls it, in-person testing? Testing is mainly an intellectually stimulating and challenging activity, although it does have some robotic repetitive processes. I think that's the problem. What are the elements of testing, the different activities? I suggest 5, not including strategic and higher level aspects. First, identify what to test and what not to. Second, design tests to effectively investigate those things. Third, build the tests to efficiently run them, whether they're manual or automated. Fourth, run the tests. And fifth, analyze the results. Do you notice any differences between these activities? As we go down the list, the activities get more mechanical, more automatable. The last two, running tests and comparing results, is what test execution tools do. Also, as we go down the list, the activities are repeated more often. Tests are generally only identified and designed once, but are likely to be run over and over again. So what are tools good at? Tasks that are more mechanical and tasks that are repeated over and over. That's where the test execution tools are so helpful. But what governs how useful the tests are? What determines whether or not these tests are effective and give value to the organization? Well, let me give you a hint. It's not how fast they run, that's efficiency. What determines value is the quality of the tests. With respect to the organization's business, their objectives, their needs at the time, the activities at the top of the list, identifying what to test and designing the tests, determine the quality and effectiveness of those tests. Effectiveness is value, efficiency is speed. Now, I said at the start that I had two concerns, but actually I believe that the second is the cause of the first. The root of the problem with tester recruitment now is misunderstanding testing and automation. This is the nub of the problem. Because some testing activities can be automated, our industry has fallen into the trap of regarding all of testing as just those mechanical activities. But, and this is a huge but, the automatable activities of testing are not all of testing. And the other aspects of testing, the non-automatable activities, are those that are intellectually challenging and creative and bring real value to the testing. This is the common confusion, that testing consists only of automatable activities. Michael Bolton has a great presentation online called What's Wrong with Manual Testing. It's a great presentation. Makes comparisons to things like music, journalism, and riding a bike, and it's very entertaining. Do watch it. You can find it on developsense.com or on YouTube. One other point I'd like to make about testing at the GUI level. If your system has human users, if it's an app, a customer-facing system, a form that people will fill out, if you test only with tools, tests that are mechanical and repetitive, you will not begin to touch the immense creativity of real human beings who don't know what they're doing. Have you ever said of a user, well, who would have thought they would do that? If you have human users, you must have human testers. Ignore this at your peril. Get your children on it, or better yet, get your grandparents to try to use your systems. Well, let's return to where we started, with the popular notion that all testers should be toolsmiths. In today's world, the jobs for testers seem to focus mainly on what tools can be used. Now, this is a bit like hiring a chef on the basis of which cookers they can use, what food processors they have experience in, or what types of knives they can wield. If this was your hiring criteria for a chef, how successful would your new restaurant be? Would your customers be saying, this tasteless and unappealing food is beautifully chopped, so it's really good, it deserves 3 stars? It's not the tool that makes either food or automated tests really good. It's what the tool has been given to work with. A tool can make things efficient, i.e. faster, but the value of the end product is not because of the tool, it is assisted and supported by the tool. In a recent email exchange, a tester said to me, I have a strong preference for manual testing, but there's so much talk of automation at the moment, I wonder if I've picked the wrong specialization. This is someone who's in the early years of their career, from what I can tell is doing a great job for the company in testing. If people like this are forced into becoming automators because this seems to be the only path forward, we may well be losing the best of our talented young testers, and our systems will suffer for it. So what's wrong with testers who want to write code? Actually, absolutely nothing. For testers who want to code, who enjoy it, who are good at it, for testers in agile teams, it's appropriate and necessary, for testers who want to extend their skill sets in a technical direction, I have no objections to testers who want to travel this route. I think it's great. What I object to is forcing this route onto every tester. One size fits all. I believe this is a dangerous attitude for testing in general, and here's why. Not all testers will be good at programming or want to become developers or toolsmiths. Maybe like Alex, that's why they went into testing in the first place. Hans Buwalda says, you may lose a good tester and gain a poor programmer. This attitude of every tester has to be a toolsmith implies that the only good tester is one who can write code. This demoralizes and devalues those testers who are specialists and experts in human in-person testing. It also devaluates testing skills, which are quite different to development skills. It ignores the cognitive and intellectual facets of testing, which is what makes testing so useful and valuable, the non-automatable parts. And it leads to the mistaken but all too common management attitude of, let's fire all the testers and just get the right tools. Oh, one more thing. You might be thinking, well, why don't we just get the software developers in test to do any non-automated testing that needs to be done? Yes, that can work, just as getting a tester to do automation can also work. But the same argument holds. Just as not every tester would make a good automator, not every automator would make a good tester. If you have both skills in one person, that's absolutely great. But do make sure you have both skills within your organization. Don't inadvertently throw away the in-person testing expertise that you have built up over years just to follow a popular trend. So, what should you as a manager do about this? Rather than hiring only testers who can write code, should you hire only human testers? Certainly not. Neither extreme is right. You need both. Automation is essential to your business survival. Automation is necessary in continuous integration and delivery. You need to have people who are skilled in tool support for testing, whether they started out as testers or developers, but understand the limitations of automation. Be aware that the gaps that an automation-heavy strategy has, and most important, be aware of all aspects of testing, both automatable and cognitive. So 5 points then to conclude. In order to do both testing and automation intelligently, first, be aware of the gaps in automated testing and ensure they are addressed. Second, invest in your automation to get robust, maintainable, and long-lived tool support. Third, understand that the sort of test activities that tools can do is only part of testing. That's the common confusion. Fourth, don't devalue and discard what might be your most valuable assets, the human in-person testers. Appreciate them and reward them. And last, have tools do what tools are good at and have people do what people are good at. Thanks very much.
Hi everyone, welcome to my talk on A Leader's Guide to a Quality Culture. Today I'm going to talk about some ideas I have on how we can influence or change the culture of our teams to embrace quality more, not just testing, but quality all up. And I'll share some guidelines and models I've used to help improve quality culture on teams over the last few years. I'm Alan Page, and let's go ahead and get started. The first thing to figure out here is what exactly is a culture of quality? If I were to ask 10 of you, I'd probably get at least 11 different answers. So today, we'll dwell a little bit on what exactly a culture of quality is. Then I'll talk a little bit about how you can drive or lead your teams to change their culture, which is a hard kind of change. And then I'll talk about some practical examples and a model I've used to help improve the quality culture of an organization. Of course, quality is much more than testing and something I care deeply about. In fact, I care about quality much more than I do about testing. But let's get back to that original question. What is a culture of quality? And I find this quote from Justice Potter Stewart. It's pretty famous. It's often paraphrased. I don't know what it looks like, but I'll tell you when I see it. And in this case, he's talking about pornography, but in the case of a quality culture, it can be the same thing. So the question remains, what is a culture of quality and what does that look like? I'm inspired by one of my favorite books here, a treatise on the culture of quality, Zen and the Art of Motorcycle Maintenance, where Robert Pirsig basically says, again paraphrase, that quality and care are two sides to the same coin. So, which is great, and if you think about it, it makes sense. If you think about products that are well built, whether they're software or hardware or electronics or anything, care does have a correlation with quality. Measuring care is fairly difficult. So, but there's something there. So I like to think about this quote when I think about what a quality culture is, but it's not the whole answer. So I'll get into a little bit of how I defined it in a minute, but let's talk about the real hard part of this first for just a few minutes. And that is, how do you take a team, an organization, a company, from a place where you are now, wherever that is, whatever your level of quality, whether it's what you think is a very high level and you want to make it better, or a very low level of culture of quality and you want to improve it. How do you go from where you are now up to a level of a quality culture that you see as your ultimate goal? The first thing between those two things is to define the current state and the desired state. The current state should be pretty easy if you're paying attention to your organization. The desired state is where you want to be at some point down the road. It can be 6 months, a year, no time frame involved at all. What you want to do is define current state, desired state, and then just the next steps. The only thing you can control now are the next steps. What you'll find when you work in a model like this, and it's probably a lot of head nods on this one if I could see you, pretty much common sense. We can only do now what we can do now. So, but if you define the desired state, and the desired state could be something way out there, like I'm not even going to try and fathom a unrealistically high culture of quality, but define where you want to go. What do you want to be known as? What do you want to do? And then figure out the next steps you can take. And then after the next steps, reevaluate. What I found in using a model like this is that the desired state changes, and that's fine. But those next steps always help you move forward. This concept of desired state and current state comes from a book called Leadership on the Line by Ronald Heffitz, which is one of my favorites, which has one of my most quoted quotes, my most repeated quotes on leadership, which is that leadership is disappointing people at a level they can absorb. Which, if you think about it, makes a lot of sense. Leadership is a lot about making decisions. Leadership is a lot about sometimes making decisions that aren't popular with everyone. And that's fine. It's part of what we do. A line I just used today a couple times in a meeting is that alignment is not consensus. Sometimes consensus is the right thing to do. Often it's a slower thing to do. Of course, you don't want to make a lot of enemies and leave bodies in your wake, but sometimes as a leader, you will make unpopular choices as you move people forward. As long as they can see the value in what you're doing in progress, it's at a level they can absorb. Another thing this book talks about a lot, in fact, the entire book is about this differentiation between technical challenges and adaptive challenges. And technical challenges are the things a lot of us face every day. They're relatively easy. They could be a hard implementation problem in software. It could be developing an entire feature or a feature set, but it just requires work. The challenge is fairly easy to identify and scope. The solution is clear. Of course, it may involve weeks and weeks or months of work, but the solution is clear. And a relatively small number of changes and can be completed relatively quickly. Implementing a new debugging system, adding a new window system, technical challenges. But Heffitz differentiates those with adaptive challenges, which fall very much into the realm of changing a quality culture. And in an adaptive challenge, it's difficult to identify. Solution's unclear. It requires system thinking because the changes you need to make may be required in multiple places. They may be process changes or technical changes or people changes. And it requires a lot of experimentations and discovery. It's kind of like building the plane while you're flying a little bit. Need to look at that desired state and move forward and adapt, paying attention to what's happening with the system, paying attention to what's happening with the people involved, and making sure things are moving forward. These are by far adaptive challenges and much more difficult, but it's a kind of challenge that as you grow in leadership, I think you take on more and more and more. Moving from a leadership position where you are leading the work a team is doing towards leading the team towards a vision which requires more than just technical work to accomplish. This sort of mindset, and if you're interested in changing the culture of a team or moving a team who may be set in their ways in any ways where they may not agree with your decisions, I highly recommend this book. It's not a blueprint, but it'll give you some ideas on how to take on some of the challenges you'll run into. So book blurb over. It wouldn't be a presentation by me if I didn't include at least one book reference. But for the remainder of this talk, that's kind of the setup on how you can go about doing this. But rather than be all hand-wavy and theoretical, I want to talk about the practical ways I've been able to get teams to improve their quality culture. And that's my dog is here to help. She's here to help make it practical. Let me start with how this practical guide came into being. Of course, many years ago, I read Continuous Delivery when it came out, and it had, I'll show you on a screenshot on the next screen, a maturity model on DevOps. But when Accelerate came out, and this book's been very popular the last few years, I'm sure a lot of you have read it, a lot of great information from this book, but also Accelerate had a section talking about maturity models and how they didn't like them, which resonated well with me. So I had been reading, Accelerate had just come out, and I had read it for the first time. And I was in a meeting where my manager asked me about a quality culture. And because I love to take on things I don't know how to do, I said, you know what? I think I can define what a quality culture is. So I had Accelerate in my head, and that made me go back to Continuous Delivery book. And then I saw this, of course, colorized chart from Continuous Delivery. It's a maturity model. The idea is you move from not being so good at something to being very good at something with some intermediate steps in between. And then there's a little bit of a model here from Accelerate. Again, it's not a maturity model here because Nicole Forsgren, the author of that book, and I are highly agreed on the pros and cons of maturity models, and mostly cons. But these things ruminated in my head, and I thought, I was going back and thinking about all the times I had worked on teams, and the teams that had what I thought was a high quality culture versus a low quality culture, or less of a quality culture. I tried to figure out what were the attributes of these teams. Certainly, it was hard to measure care, of course, and certainly it was much more than bugs. But what was it? And it's one of those things where the idea spun in my head for a long time with me doing nothing. And this is the advantage of being a procrastinator, is that in the end, something popped up and came out on paper, and it's been pretty valuable since then. It were these attributes: testing breadth, tech debt, data. I found that very valuable. I'll talk about all of these in a minute. How the team takes on learning and improvement, which is, you could say, is an aspect of care, code quality and tools, the dev approach, test ownership and quality ownership, and leadership support. These are the attributes I came up with that describe, I think, well, in my opinion, and in my so far couple years of experience with this, describe pretty well what leads to a quality culture. And then from there, I made a bit of a maturity model, but again, due to my hatred or dislike of maturity models, I called it a quality culture transition guide. And that link I'll share at the end of the presentation as well, but share it here if you want to follow along. It looks like a maturity model, but it's a quality culture transition guide. And the idea is I wanted to describe a current state that was awful, or current state that we shouldn't say awful, a current state that a lot of teams have been in, and then a desired state, and then some steps that would help you get there. And I'm not going to go through the whole thing. That would take far too long and be probably far too boring when you can look through this on your own. But I do want to walk through a little bit of the nature of each of these. Maybe just look at the lowest state and the highest state, and just as you look through it on your own, you can see how I filled in the transition to get from one end of the transition guide to the other. Before we go into it, and probably it's a good place to rant a little bit more about maturity models. All models are wrong. Some are useful. I do see people with loud voices on the internet throwing out the baby with the bathwater and saying that a model, for example, I should start a holy war here with the testing pyramid. All models are wrong. Some are useful. What I'm about to show you here, the same story. Very quickly, what I dislike about maturity models is that when I worked with a little bit with CMMI many years ago, Two things I noticed. One, there was I don't recall if it was a requirement, but a strong preference that you move in lockstep all the way from every attribute across the model from one level to another. I think you may make conscious and good business decisions to not improve all your quality model at once, or your quality culture, and it may make sense for you to move parts of it in different rates than the others. Also, I'm very much against the idea of hiring some consultant to come in and evaluate where you are in this model. Probably a couple of you have already opened up the spreadsheet that I linked to on the last slide, and this is not a scorecard. Don't give your team a red, yellow, or green. This is something you can use to start communication on your team. And I have teams pull it out in retros all the time. It's a way to figure out what are some things we're not doing today we may want to do differently that we think will help improve our culture of quality and thus improve the quality of what we're delivering to our customers. So, caveats aside, let's dive into a little bit what this is so you know what I'm talking about and how I use this. First one is quality and test ownership. On one end, testers own quality. They're blamed for bugs. Some of you have lived in this world. Some of you may still live in this world. I hope not. At the other end, as some of you know from looking at my writings and other talks on the internet, I believe that developers can own the vast majority of testing, including especially owning all or almost all of automation. And teams may choose to get to a point of quality and test ownership where they do not need a dedicated quality specialist. That is a rat hole I won't go into deeply today, but I've seen it happen, and I've seen very successful teams have a very high quality culture without having testing specialists. Doesn't mean you don't need them. Some teams and contexts need them. You can decide that on your own, but that's one level you could reach there. Next one is the breadth of testing, and often I reference the Agile testing quadrants from Brian Merrick, and then which were then expanded by Lisa Crispin and Janet Gregory in their Agile testing book. I find the quadrants a really good way to understand different aspects of testing a team can do. And again, some people have dismissed these and rewritten them. All models are wrong and some are useful. If you don't like something, that doesn't mean they're useful. This is a little bit of a trigger point for me, as you can tell, so I'll move on. But on one end of testing breadth, you're entirely focused on a bunch of functional tests. Test cases to verify a bunch of happy path stuff. You don't really do anything else. But on the other end, everyone on the team is involved in creating this multi-dimensional, multifaceted test strategy that covers almost everything you can think of. Not over-testing, but covering the right amount of stress and perf and load and everything else in order to make sure your product is going to be acceptable and provide value to your customers. Very much overlapped with testing ownership, because I do expect at this highest level for the whole team to be involved, but definitely a reachable level. And again, to remind you, I have two levels here. I've given them some names stolen from some other maturity models. There are other levels in there with much more text, just trying to get to the gist of what these cover today. The next one's tech debt and maintenance. Probably the biggest example here is the bug backlog. I have found that teams that have a low quality culture also love to hold on to lots and lots of their old bugs. Incidentally, I have found that average bug age by itself is a pretty good indicator, or has a pretty good correlation with what I see as the quality culture of a team. So it's something I do look at on new teams I work with. As teams mature here and get really good at this, it's not just bugs, but it's other tech debt. Tech debt is dealt with regularly. But often teams at a high level of a quality culture, they don't have a bug backlog. When a bug comes in, they either decide to fix it right away or postpone it as needed, or not postpone, or resolve it as needed. They just don't tolerate debt. It's like the difference between the person who pays their minimum payment every month on their credit card versus the person who always makes the full payment because they just don't want to deal with debt and the interest that goes along with that. I could argue that interest with tech debt is even more expensive than your worst check cashing place, but again, that's a whole other talk. Another category is code quality and tools. In some teams, Just compiling your code with a very low warning level is enough, and ignoring the warnings that do get produced is on one end of the scale. On the other end of the scale are teams that not only use the highest level of warnings, they fix their warnings, they add additional linters, and linters are static analysis tools, things that can find not just syntactical bugs in your code, but everything from spelling errors to geopolitical issues to offensive names that may show up in the customer code. I've found that teams with a high level of equality culture tend to run a lot of these tools in their CI systems, a lot of analysis on code. They like using the computer to help improve the quality of their code. The story I often tell here is the time I was frustrated because working on a web product at my old job at Microsoft, and about twice in 2 weeks, someone broke HTML code, like they missed a closing tag. And granted, it was in Angular, so it was a little obscure, but they were breaking HTML. And I said, I'm going to grab a HTML linter off the internet. I'll get the one with the most stars on GitHub. I integrated it into our pipeline. And again, coming from a test background, I'm very careful when I check in production code, and I'll call production code our pipeline code. Lots of code review. I tested it a lot. I wrote unit tests for my linter, made sure it worked. I checked it in, and the very next build broke, and I felt really bad because I carried guilt with me when I break the build, and I wanted to see what I screwed up and what obscure thing I messed up and putting this thing into our CI system. And I didn't. My work was actually good, but the very next check-in after my linter was someone who broke the HTML. So that's there cemented. Like, I got the value of the work in adding this linter within seconds, if not minutes, of me adding this. So pretty good quality culture on that team as far as code quality and tools go. So point made. Moving on to the next one. This is something that a lot of teams don't take advantage of, which is looking at customer data. I truly believe that only the customer can evaluate the quality of our products. So without data, unless you only have 5 customers, you can talk to them, or whether you want to interview 5,000 customers or more if you have them, we have to use data to understand whether or not the customers are being successful using our products. There's no way to tell otherwise. So a question, the teams with a high quality culture, for everything they're doing, they're thinking of it in some way as an experiment. They're going to have a hypothesis on why this change is important, and they're going to use data to understand if the change is having the impact they wanted it to have. On the other end, as I'm sure is true with at least a couple teams here today, the customer data, and we're not talking about PA, we're talking about customer usage patterns, is ignored. So there is a correlation here. If you really care about your customer, you need to understand how they're using your product. The development approach is also important here. And this is, I'm sure a lot of you are having agile practices. We've all been on the other hand, on cowboy teams where everyone did what they want. Done is not only not defined, done is someone else's job to go do as we test quality into the product. Hopefully none of you are in a team like that. But on the other end, and again, this is a lot stolen from Agile. And in fact, a lot of my thoughts this is all centered around Agile and lean startup and things I've seen teams do when they've been consistently successful in delivering products that customers like. But in a mature team, feature development is really well organized. The teams have a good planning process in place. They're able to break things down into the right size pieces. Throughput is generally good. And as within data, they're doing a lot of experimenting in order to understand whether or not what they're doing is the right thing. And then learning and improvement. So I think, Peter Senge wrote in The Fifth Discipline that the learning organization is the hidden or the untold competitive advantage. And on one end, you can have a team that just does their work, doesn't bother to learn. But if you have a team that embraces learning through, whether it's through analyzing incidents or whether it's through doing frequent retros on the team, those teams tend do a lot of the other things on this list because they find lots of areas to improve. And they find that taking that time to reflect on what's going well and what's not going well is a benefit for their team. So again, it should be a head nodder there, but not enough teams take advantage of the retrospective. I have said before, and I'll say it again, is that other than your one-on-one with your manager, I think a team retrospective is the most important meeting your team can have. Some may disagree, but that's my stance. And again, I'm going to repeat what I said before because it's worth repeating. It's not a blueprint. It's not a scorecard. It's a conversation starter. It's great working backward. It's great for it to come out in the retro. But often the way I introduce this to a team is to just have them read the chart. And again, it's the full spreadsheet is linked. I'll have it on the next slide. But have them read through it, self-evaluate a little bit. It can be on their own or within a team discussion. There's no right or wrong answer. If you find yourself debating on whether you're at level 2 or level 3, it's not the point. Have a discussion about kind of where you are and have some alignment on where you are. Remember, alignment is not consensus. And coming out of that meeting, just like with a good retro, once you've reviewed what's in this transition guide, is come up with 1 or 2 things, maybe 3 at the most, but I like 1 or 2 that you think you may want to improve. Like looking at your team, go, wow, we're really good here. We're not so good here. It may not be the lowest thing you want to improve, but you want to pick the low hanging fruit. I'm a big fan of the matrix that shows effort and impact. I love to do the low effort, high impact work. So it's just adding a linter if the team's going to pay attention to it, or something else where you can go, I can just do this one little thing that's going to make a big difference here in what we do. In fact, low effort, high impact for me, if your team's not doing retrospectives, start doing retrospectives. Just remember to refer to it frequently. I've found, and lots of my teammates that have used it, and even some folks outside of where I work have used it, they find just a valuable reference to go back to and think, okay, how are we doing here? Are there things we're not doing? How can we improve the way our team works to deliver software that our customers love? So that's just a crash course on my guide to improving quality with a few tips on how to go get that done in a way that the team will adopt. And there's the link again. You can follow my blog at angryweasel.com. Of course, moderntesting.org is where the homepage of the A/B testing podcast, which you're also welcome to listen to at any time. And you can send questions my way either through one of those places or in the panel discussion coming up, or if I time this right, maybe right now. We have a few minutes, so why don't I just end this and I'll take some live questions.